In part 2 of our lesson on radian measure, you're going to learn about converting between degrees and radians. Now in part 1, we learned that 180 degrees was equivalent to pi in the radian measurement system. When we are converting from degrees to radians, then, we're going to multiply our angle by pi over 180 degrees. That's our conversion factor. And when we're converting from radians to degrees, we're going to multiply our angle by 180 degrees over pi. Now you might wonder why we're leaving the units off of the radian measure. We don't put pi radians down here or pi radians up here. It's customary to leave the units of radians off. So if you see an angle written as theta equals 7, then that would mean that angle is in radian measure. It would have to say theta equals 7 degrees for it to be in degrees. So you assume it's in radians if there's no units. You only find out it's in degrees if the degree symbol is there. Let's look at this first example. We have to convert theta equals 165 degrees into radians. So we know theta is 165 degrees. We know we're going to multiply by our conversion factor. Now we're converting from degrees to radians, so our conversion factor is going to be pi divided by 180 degrees. And it's pretty easy to see because we have degrees in the numerator. We want to get 180 degrees in the denominator so that those units will cancel out. Now because 165 ends in a 5 and 180 ends in a 0, we know that they have a common factor of 5, so we can go ahead and reduce. We know that 5 goes into 165 33 times, and 5 will go into 180 36 times. Now we see that we have a common factor between 33 and 36 of 3. So if we take 33 and divide it by 3, we're going to get 11. If we take 36 and divide it by 3, we're going to get 12. So we can see that theta is going to equal 11 pi over 12. And notice we leave the units off because that indicates we're using the radian measurement system. In this second example, we have to convert theta equals 5 pi over 6 to degrees. So let's start by writing our angle, 5 pi over 6. It does not have any units next to it, so we know it's in the radian measurement system. We want to convert it to degrees, so we know when we're converting from radians to degrees that we're going to multiply by 180 degrees over pi. So that's our conversion factor, 180 degrees divided by pi. Now we can do some canceling here. First off, we see that pi in the numerator is going to cancel with pi in the denominator. We also see that 6 is a factor of 180, so 6 goes into 6 once. 6 goes into 180 30 times. And we see then that theta is going to be 5 times 30, which is 150, and we have the degree symbol left. In this next example, we have to convert theta equals 81.7 degrees into radians. So we start off writing down theta equals 81.7 degrees. And now we know we're converting from degrees into radians. So we're going to need to multiply by our conversion factor of pi over 180 degrees. This is not an easily reducible fraction, and in fact the instructions asked us to round to the nearest hundredth, so we're going to pick up our calculators to find out what theta is equal to. So we know that 81.7 is the same as 81.7 over 1, and now we're going to multiply straight across. So grab your calculators. We've got 81.7 times, here's the pi button, then we'll have to divide by 180 and hit enter. And we can see that rounding to the nearest hundredth, we're going to get that theta is approximately 1.43. And we know because no units are indicated that it's in the radian measurement system. Next, we have to convert theta equals 4 to degrees. So we have theta is equal to 4. Because no units are indicated, we know that's radians. Now we're going from radians to degrees, so we know that our conversion factor is going to be 180 degrees over pi. We know that 4 is the same as 4 over 1, and now we're ready to pick up our calculators and see what we get for theta. We're going to multiply 4 times 180, and then we have to divide by pi, hit enter, and rounding to the nearest tenth, we see we're going to get 229.2 degrees. Now that we know how to convert angles from degrees into radians, we can go all the way around the circle now, converting all the special angles in each quadrant into their radian equivalent. So if we take a look at 30 degrees, we know we could do that conversion. If we're going from degrees into radians, we know we're going to multiply by pi over 180 degrees, and 30 goes into 180 6 times, so 30 degrees is equal to pi over 6. "45 degrees, we know we're going to multiply by the same conversion factor, pi over 180 degrees, and 45 is going to go into 180 4 times, because think 45 times 2 is 90, and then 90 times 2 is 180. So 45 goes into 180 4 times. So this is pi over 4. We know 60 degrees. We can multiply times pi over 180, and 60 goes into 180 3 times, so this is pi over 3. Now let's go ahead and label the quadrantal angles because we already figured those out previously. We know 90 is pi over 2. We know 180 is pi. 270 is 3 pi over 2. And 360 is 2 pi. Now we can go around the circle doing that calculation for every one. We could take every single angle and multiply it times the conversion factor of pi over 180, or you can start to think in radians, which you're going to need to become fluent in radians as the semester goes on here. And let's start thinking about reference angles. We know that 150 has a reference angle of 30 degrees. Well, that's going to be the same now as having a reference angle of pi over 6. So in your head, it's probably pretty easy to do pi minus pi over 6, right? What you're thinking in your head is pi minus pi over 6. Now you know pi is 6 pi over 6, so 6 pi over 6 minus pi over 6 means that 150 degrees is going to be 5 pi over 6. I'm trying to help push you towards a skill you're going to need to be very good at, which is thinking in radian measure to find your reference angles. Now if we go to 135, we know that that reference angle is 45. So if we come over here, 45 degrees is the same as pi over 4 in the radian measurement. So if we start at pi and we back up by pi over 4, then what we're thinking is pi minus pi over 4 is 3 pi over 4. And again, if you're having trouble thinking of that, what we just did in our heads was pi minus pi over 4. Pi is the same as 4 pi over 4. So 4 pi over 4 minus 1 pi over 4 is 3 pi over 4. A 120, we know the reference angle in degrees would be 60. If we come over here to 60 degrees, that means the reference angle in radians is going to be pi over 3. Then pi minus pi over 3 is going to be 2 pi over 3. All right, now I want you to think in terms of reference angles now and finish getting all of the equivalent radian measure angles for the rest of the angles on the circle here. So pause the video and restart when you're ready to check your answers. Okay, now thinking in terms of the reference angles, we know that 210 is going to be equivalent to starting at pi and going over by a reference angle of pi over 6. So pi plus pi over 6 is going to be 7 pi over 6. at 225, that's going to be equivalent to starting at pi and doing a reference angle of pi over 4. So pi plus pi over 4 is 5 pi over 4. And here at 240, where the reference angle is 60, we're going to now think of the reference angle as pi over 3. So pi plus pi over 3 is 4 pi over 3. Now in the fourth quadrant, we know we have to find our reference angles if we were in degrees by backing up from 360. So here we know from 360 to 330 in degrees, our reference angle would be 30. So instead we're using pi over 6. So we have to start at 2 pi and back up by pi over 6. Now 2 pi minus pi over 6, we know that 2 pi would be the same as 12 pi over 6. So 12 pi over 6 minus 1 pi over 6 is going to be 11 pi over 6. Here at 315, if we're in degrees, the reference angle is 45. So in radians, the reference angle is pi over 4. So if we start at 2 pi and we back up by pi over 4, that means 2 pi you have to think of as 8 pi over 4. So 8 pi over 4 minus 1 pi over 4 is 7 pi over 4. And finally, 300 degrees, we know the reference angle is 60 degrees. We're going to now start thinking of that reference angle as pi over 3. So if we do 2 pi minus pi over 3, we have to change this into 6 pi over 3. So 6 pi over 3 minus pi over 3 is 5 pi over 3. And there's all the special angles going all the way around the circle. Now, using all the positive angles that we just figured out, we can go ahead and just fill in the circle going in the negative direction. So we know negative 30 is going to be negative pi over 6. Negative 45 will be negative pi over 4. Negative 60 is negative pi over 3. Negative 90 is negative pi over 2. Negative 120 is negative 2 pi over 3. Negative 135 is negative 3 pi over 4. Negative 150 is negative 5 pi over 6. Negative 180 is negative pi. Negative 210 is negative 7 pi over 6. Negative 225 is negative 5 pi over 4. Negative 240 is negative 4 pi over 3. Negative 270 is negative 3 pi over 2. Negative 300 is negative 5 pi over 3. Negative 315 is negative 7 pi over 4. Negative 330 is negative 11 pi over 6, and negative 360 is negative 2 pi. So there's all the equivalent radian measurements going around the circle in the negative direction.